So everyone, welcome. Welcome back from the break. ENDORSE 2021, the European Conference on Reference Data and Semantics. This is day one. We're focusing on reference data governance. It's mind-boggling to me as someone who's not a data type guy. I mean, I do like to surf the net, but it is very interesting to look at how the EU manages itself of 27 countries with 24 official languages and a digital single market. How do we make this digital revolution work? And ontology was something fascinating to me to see how things evolve. Now, I'll get out of the way on this as soon as I can. Tech tips, you can send your questions in the chat. We're going to try to stay on time so we can get to the questions after each speaker. The hashtag ENDORSE 2021. If you have a good soundbite that you hear, you'd like to cast it wider. Speakers, make sure to look in the camera. Microphones are off when you're not speaking. And this will be recorded for playback for anyone who does happen to miss it. Now, let me get quickly to, we're talking on track 2 on solutions. And this is about W3C data catalog vocabulary DCAT. And who's going to talk about this? Peter Winstanley of Semantic Arts. Peter, your Semantic Arts works with companies that want to be truly data-centric, where all content exists in interoperable formats. And Peter, you've also worked for the Scottish government as data interoperability specialist. So you're going to give us a bird's eye view of DCAT. And there are lots of catalog systems out there. Why DCAT, Peter?
Thanks very much, Chris.
There you go. Okay, good.
Can we see the slide? Right.
Sure do.
So what I would like to talk about today is the W3C data catalog vocabulary. And it comes after really quite a shocking year for everybody with COVID. And one of the things that happened when the COVID epidemic started was that all manner of organizations had to suddenly find information that they really didn't know even if they had it. And then when they found it, they had to sort of pull it together. Things like finding vulnerable people in their area, things like finding resources to use to help these vulnerable people, various other things like that that are part and parcel of the operations of our local civic society. The difficulty was that being unable to find things was simply because the information wasn't organized in an appropriate way, wasn't necessarily interoperable, both in terms of exchange or in the ability to integrate information brought in from many different sources. And it is through metadata that we actually find things. So the W3C data catalog vocabulary that I'm going to talk about is a way of creating catalogs that are appropriate for publication on the web or using web approaches. And it provides us a lingua franca for supporting the interchange of catalogs that makes things like federated query, aggregation, and so on simple. This isn't to say that it's the only show in town. There are many others. But the idea of the DCAT, the data catalog vocabulary, is that it's an interoperability standard. It's made up of 3 principal classes, 3 principal component parts, and one which is used to sort of add a little bit of narrative when we need it. So there is a catalog, there are resources, and there are distributions. And then we can make notes in the margins using a catalog record. What I intend to do is to go through how these fit together in the model, and then I'm going to talk very briefly about how you can begin to implement this in your area. So the catalog is basically a container for pointers to data sets. You add to it metadata. Metadata is the sort of information that you have to help you find things in the catalog that you've got. So the catalog metadata is metadata about the catalog. It helps you find the right catalog. If you want to put other margin records in, you can do that within the catalog record, but otherwise it's got a stack of data sets. Data set is described by a whole bunch of metadata, and then there will be some access point, something that will tell you how you might get access to that data set, which is probably a web page or something like that. But the thing is that a data set is to some extent a kind of abstract notion. But actually what happens is that we get data sets distributed to us in different ways. It might be an Excel spreadsheet. It might be a CSV file. It may even be a publication in a book or a PDF. It's still the same data set, but these different ways in which we access it are what we would call distributions. And a distribution is going to have some metadata that helps us find it. But the distribution may also have a specification, something which tells us what it conforms to, which would help us work out whether or not it's the right form for us to use it. Again, there's an access point, and sometimes, particularly with big distributions, these don't come in a single download, but they come from a data service. If you go and take a look at the W3C website, the standard is published there, and this shows you how you can link the different elements that I've described to the diagram of the standard that's in the publication.
So how do we use that catalog, Peter? How do we make that work? How do we use it?
Well, what I would like to describe here, Chris, is how we might begin to put a catalog together. So we want to decide that we want a catalog, so we'll create an identifier and put in some details along the lines of who the publisher is, what the rights and policies are for the catalog, and other metadata that helps us understand what the catalog is about, including whether or not we're using a particular classification, taxonomy, or theme. And then we're going to add into it data sets. And these are identified as the class data set. Now, most of this is described for situations where we would use RDF, but it's entirely feasible to do this in any other way that you want. You could do it in XML, or you could even do it in a relational model. But most people will be doing it using linked data, which you'll hear about a lot in this conference. Data sets may be created from other resources using a workflow process, and you can use provenance vocabularies, such as PROV or PPLAN, in order to create information, additional metadata specifically about the workflow process. A distribution, as I mentioned, is the way in which most people actually get the data, and this could be many different distributions for one particular data set. And we may want to tweak the distributions to make sure that they're in the right language for people to use, or that they restrict to remove personally identifiable information or other things like that. The data service, again, it is often the case that we end up with data being accessible through APIs, and the data service class is the appropriate one for which to describe how distributions can be accessed through these services. Sometimes we need a bit more metadata. We need to put in some notes in the margins, and we can use the catalog record as a class for that purpose. Sometimes we have data sets that aren't a single source, but they're actually a kind of bundle of files. And it's entirely possible to mark that up within a DCAT record, where we would use the Dublin Core term relation to relate the dataset identifier to the component parts, this bag of files. One of the other things that you will hear about a lot in many areas these days are the FAIR principles, the principles that say that information should be findable, accessible, interoperable, and reusable. And the F of findable is definitely something that a catalog record is about. And so we can use the Dublin core is referenced by to go from the record of the data set to a document that actually talks about how that data set is used in a publication. We also need to think about quality, because it's often the case, Chris, that we have incomplete data. We need to know about it. And so we can use the W3C data quality vocabulary within the description of data sets and distributions in order to describe quality metrics. Now, we know that when we use RDF, we're using what we call an open world assumption, where anybody can say anything about anything. But often it's the situation that we need to check, have we got a complete record? And so we can use shape constraint languages. You will hear in the conference about shape constraint languages such as checks or shackle. And we can use these in order to show that we've got a correct or an adequate record in the way in which we're creating them and adding them to our repository. There's also a situation where we want to think about versioning. There is a certain amount of information on versioning within the most recent incarnation of the DCAT standard, but this is something that the W3C Dataset Exchange Working Group are currently working on to provide more information, more guidance for version 3. And you'll see.
Peter, can you explain what versioning is?
Yeah, there's different approaches towards versioning. It may be that what I have is a data set that is in preparation and it's in draft, and then what happens is that I pass it for approval, and then we end up with the version that we're using to actually work with. So that's one aspect of versioning, which is to do with the life history of a particular data set. But it could also be that what we have is a 2019 version of a data set and a 2020 version of the data set. So sometimes these form versions which are real versions. We've done a different survey. Or it could be something where we're accreting, and we're also working on that, where you have a data set series. So there are different interpretations of it, and this is why working on versioning and having an appropriate approach to that in the metadata can be challenging, because there are different aspects of versioning which are relevant depending on the situation. So that's the end of my talk. It's an overview. I'm hoping that people will both see DCAT being used widely across member states in their open data assets and in other things like the ongoing work on the catalogue of services. But also I hope people will find that it's not too intimidating to use this as an interoperability standard for a very wide range of information assets.
Okay, Peter, thank you very much. We talked a while ago about how data snaps together automatically like Lego bricks. I mean, that's the way you'd like to see it work, right?
Yes, it's absolutely right, Chris, that if what we use is a system of URI identifiers and controlled vocabularies, ontology models like DCAT, what we can do is mint our records and then share them with others, and they will deduplicate and aggregate together and orientate themselves using the linked data model so that people can navigate their way through them and so that they can aggregate and query them in exactly a consistent and same way for each of the data from different sources.
Okay, let me see if there are any questions at this point. I think we need to wrap this up very quickly now at this point. Just very quickly, what do you think the Brexit impact would be on this? This could be a whole conference on that, but what's the impact of Brexit on data?
Well, I think that there are many open data efforts, shall we say, from many different countries and member states, and I don't see that these are going to be significantly affected.
Mm-hmm.
When it comes to administrative data, there are clearly situations where we've previously had agreements between the UK and other member states, and these need to be re-agreed. So, you know, there's a lot of work to be done on ensuring that these channels get revisited.
Right, right. Peter Winstanley, thank you so much of Semantic Arts. That was great. It was a good start for this long session on solutions. Thank you very much.
Thank you very much, Chris.
And let's move on now to building a metadata space for cultural heritage at Europeana using best practices for modeling, enriching, and sharing data. We're talking to Antoine Isaac. Welcome, Antoine. You're with Europeana. You're R&D manager for the Europeana Foundation. You worked on representation and interoperability of collection of their vocabularies. Europeana gathers metadata to enable access to a wide range of digital cultural collections from libraries, museums, and archives. That's a big job, Antoine. Tell us about how you're building a metadata space for that. Antoine, can you turn your mic on? I see you are with us, but I think you need to turn
yeah,
mic on.
that should be okay now, yeah.
Okay, that's great.
Sorry, I had started sharing and then I missed the button for unmuting. Yeah, so thanks, Chris. Indeed, there's a lot of work to do to build across the metadata from various cultural heritage institutions. And in my presentation today, I'm going to try to go through various pieces of technology that we've tried to use to meet those goals. So it's going to be rather like an explanation of a journey rather than a focus on a specific solution. So it's about what different technologies and how to make them work. So first, maybe a bit of a reminder about what is Europeana for those here who would not be familiar with what we do. So we publish over 50 million digitized objects coming from 4,000 libraries, archives, and museums across Europe. So that's currently from 44 countries. And that data set is growing on a daily basis. So tomorrow the figures will probably be different. And concretely, what happens in Europeana is a sort of data flow, and by data, Europeana means mostly metadata. So we gather metadata that comes from memory institutions. So again, libraries, archives, and museums. And this metadata has pointers to digitized content, but Europeana does not host the content itself. So we gather the metadata that then point to the digitized content which still exists on the original provider's websites. And another aspect of this data flow is that very often we don't get from the institutions that provide it. We get it via a network of what we call aggregators, which are organizations or projects that gather data from a specific country or a specific domain, such as music, fashion, etc. And that is quite important in terms of the consequences of the shape of the data. As a matter of fact, we must harvest and process metadata that's very heterogeneous. So we've got many different domains, themes, and types of objects. We've got different data models that exist at source, and we've got many languages. So I'm not going through all these items on the slide. The idea is just to tell you how diverse the situation is and how complex this landscape is. And from that heterogeneous landscapes, how to get to some more homogeneous, richer and multilingual data that we could make for users. Well, like many data aggregators, we ask our providers to use one model, so to simplify the work for us. And in our case, we've called it, without any originality, the Europeana data model. One key point in that proposal of the model is that we cannot do whatever we like. So we do not operate in isolation. Our approach must be easy for our partners. It must also be rewarding in terms of the value they get for their effort. And we must do everything based on community agreed best practices. So there's really no way in coming with our own solution that would reinvent everything from scratch and not look at things that happen around us. So one of the key things our approach is based on, and that won't be a surprise, in this conference is linked open data and the best practices that go with it. So again, on this slide, there's a video. I'm not going to play this. This is basically something that we've made to explain to our partners and to the wider cultural heritage domain how linked data can be useful. And since we've got a bit more time today, I'm going to actually talk through some of the elements why we believe linked data is useful, and actually some elements for which it has really proven to be useful for us. So in terms of the modeling proposal, so the Europeana data model, and here is a brief example on this slide. It basically takes a stance at traditional metadata by creating, well, kind of splitting it basically. So each element in the metadata can be considered as a fully fledged resource. So we don't have the series of basic strings that used to exist in traditional metadata catalog. The Europeana data model, following the linked data approach, try to identify the cultural heritage object. So in this case, here we've got a clavichord and various kind of entities around it. So here we've got a concept, which is the type of the music instrument. And so it has various translations depending on language. So harpsichord in English, clavecin in French, and clavecembal in German. And as opposed to the classical situation where there will be only one string, maybe clavecin because it comes from a French collection, with the linked data approach, we can make connections to things which are a bit more complex and that allow much more functionality for users. And this is achieved not by creating things by yourself, as I already hinted, but by massively reusing existing vocabularies. So instead of minting our own classes and properties for the object that we're interested in, we've looked around and we use quite a lot of existing data models and vocabularies. So again, I'm not going to spell out all the acronyms on this slide. But it is intended to be to give you an idea that we do actually try to reuse whenever we can. And actually, sometimes for a vocabulary, we've used only one property because, well, we thought that it was better to rely on this careful work of defining things elsewhere, having some experts who have worked on their topic for a long time, rather than to try to invent things ourselves. So equipped with this model, we've got a base for enriching metadata. And in our case, this is mostly about linking to multilingual metadata. So as I said, we've got, with our data model, data as resources that are equipped with web identifiers, and not only simple character strings. So the first thing that we can do is to encourage our partners, our data providers, to contribute with their own links to local and external vocabularies. And on the table here, so again, I'm not going to dive into all the details, but here's a representative sample of the vocabularies that we can gather with the help of our partners. So this is a set of vocabularies coming from different libraries, archives, and museums. And our providers, they can use the references to these vocabularies in the data they give us. And when we have these references, we can go to these data sources and harvest some extra data from them. And most often, this is data of good quality. It is multilingual. It has some semantic relationship. So this is mostly derived from legacy vocabularies, so thesauri, authority files, but still it's a great improvement for us to be able to tap into that data directly. And this is what linked open data enables for us.
I guess important to point out, Antoine, that that list includes places across the globe. And this is a global thing, a global way to assemble data and to interoperate data.
Yeah, basically everything we need is that these vocabularies are expressed in the data model that is rather similar to us. And because our data model basically reuses existing standards for expressing vocabularies, then the conversion is not so hard. So yes, it can come from fairly much any place as soon as it's standardized.
Right.
So in parallel to asking our providers, we also do try to do some automatic enrichment by ourselves. So linking the metadata that we receive to some reference data set for places, persons, and concepts. And we've embarked on building what we call an entity collection, which is a sort of centralized point of references for contextual entities that would be of main interest for us. So instead of relying on a purely distributed approach only, we also try to cache and curate some data that we feel could be usable across the board. So a sort of Europeana knowledge graph, so to say. And this is very much work in progress. So at the moment, it's included some hundreds of thousands of places, agents, and concepts coming from sources like GeoNames, DBpedia, Wikidata, and sometimes some more specialized vocabularies that are very useful for some of our collections. So again, this is entirely based on linked data. And here's an example of the stuff that it allows us to get. So this is the resource from DBpedia about Mozart. And it's fairly obvious that it can be really useful for us by just looking, for example, at the preferred label in all those languages. So instead of having to do translation ourselves for these entities, we can just rely on data that has been gathered, not for us, but for the greater good of the community. So this is really great. And as a bonus, it has some external links to other data sets that can be very useful for us. And actually, sometimes these other data sets, they are the data vocabularies that are used by our providers. So sort of circling and closing the loop, we can connect things together, and that's fairly powerful. Another example of metadata that we can normalize and enrich, and that's really just a node to the European Union Public Office. So for normalizing the metadata about languages, so we do get many values that try to explain the language object in our metadata. And a same language can be represented in different ways. And we have to normalize it, and we normalize it by using the publication office language name authority list. So that's also yet another example of something that's been openly provided and we can build upon. So this is a lot about following community best practices and also making it known. And actually today, this is a bit what I'm doing. So again, we try to tell everyone how following linked open data best practices is good. There are also some more focused best practices. So I want to give a pointer to some W3C work for publishing data on the web. So there are best practices that have been put together some years ago, and some of them are really useful for us in our data modeling work, such as, well, reusing vocabularies, preferably standardized one. That's not really a surprise. But then there are some more subtle aspects, like choosing the right formalization level. So not being too complex about what we do, but really trying to hit the sweet spot, the balance between something that's very simple and something that would be too complex.
Antoine, you got 30 seconds left on principe, okay?
Yep. So this is fairly much a community sport. So we do try to involve a lot of people around us. So this is a pointer to the Europeana tech community that has supported Europeana in this endeavor. And again, a couple of lessons worth sharing. This requires a lot of researching and talking. So one of the opening talks mentioned the fact that this was also about the human aspect and not only about technical work. I can fully approve that. Best practices are really useful, but access to resources is crucial. So having people publish vocabularies is great. And finally, a great deal of flexibility is useful. So we sometimes change definition to avoid committing too much to some views of the world. Easier reuse. So there's, yeah, this requires some agility. So thank you very much for your attention. And yeah, should you have any question now or later, I'm ready to answer.
Yes, I have some.
You're muted, Chris.
Okay, yeah, I clicked it and it didn't. Now it's working. Question from Tanita. Do you have a strategy in order to improve the geographic and/or thematic balance in the input coming from different data providers and aggregators?
That's an excellent question. And I must say yes and no, because we do want to balance the heterogeneity of the contributions, and that's a bit like the centralized approach that I mentioned with our building of the entity collection. So that's supposed to compensate for differences across data sets. But on the other end, because we want to empower our providers, so there's still a bit of reward for these of them who are doing a greater work at providing better data. So we don't want to hide when best practices are followed and we are getting really richer data from some part of the world or some specific institutions.
Okay, very good. Antoine Isaac of Europeana, thank you so much. Merci beaucoup.
Thank you.
Thank you. Let us move on to Irene Polikoff of TopQuadrant. She's talking about automating reference data crosswalks using knowledge graphs. And let's go straight to Irene. Irene, can you hear me?
Yes, I can. I am looking to share.
Okay. In the meantime, you are a CEO and co-founder, by the way, of TopQuadrant. You used to work for IBM, and TopQuadrant's mission is to make information meaningful, and by doing that, empower people.
Okay. Thank you for the introduction. You should see my presentation now.
Yes.
Okay. Thank you. Yes, and we have our product is called TopRate Enterprise Data Governance, and we use that to help our customers be successful in data governance initiatives. And reference data management is, of course, part of data governance. So given the nature of this conference, I probably don't need to speak much about the importance reference data of the reference data. It exists every place and found in pretty much any application, and it's used for many different use cases that has to do with data reporting, data analytics, data interoperability, and so on. So it's a very important aspect of organization's data, and caring for it an important aspect of organizational data strategy. Now, if we were in an ideal world, we would have everyone using the same canonical standardized reference data. However, you never start your reference data implementation from such a greenfield opportunity. There is typically already lots of applications out there in an enterprise. They use different reference data containing in the applications different code tables. Even for something as standardized as, let's say, country codes, there are different sets of codes. There's ISO, there's FIPS. Some organizations may have some privately developed reference data, and so on. And then for reference data in other domains, such as medical, pharmaceutical, there's really many different alternatives. And also, if you're dealing with data across organizations, in the context of data sharing and aggregating data externally, created externally, then there's always a variety of reference data that's being used, which brings us to the need to connect this reference data in order to integrate and properly understand data from different sources. Since there are many reference data sets, the approach that typically is used is creating crosswalks. Crosswalks connect two reference data sets, and you could declare one reference data set to be your organizational standard, canonical, and then like kind of a hub and spoke model, connect other reference data sets to it, or you could implement some other, one-to-one kind of approaches as well. In our product, Top Edge, this is supported by the crosswalk feature, and before you start crosswalking, everything we do in Top Edge is based on knowledge graphs. It's based on RDF and link data. So the very first step is, of course, to bring that reference data that may exist in some other systems and may have been managed in spreadsheets or whatever way. The very first step is to bring it into Top Edge, translating it into RDF and making it part of the knowledge graph. And that is done pretty much automatically. There are importers from different sources, including from a spreadsheet. So basically, a spreadsheet like this is an example of the currency codes with different fields. Once translated in the knowledge graph, they become links or properties brought in, and you get a reference data set that is now represented in the graph and therefore linkable, easily linkable and connectable as something like this. And then you could go on and create a crosswalk, identifying your reference data sets and identifying the entities that you're connecting. There's many ways to do relationships in a graph. Specifically crosswalks tend to be about mapping two sets of data sets about the same entity, such as country. So here you see FIPS codes and ISO country codes. And with that, you've got your crosswalk, but at this point it's empty, it's not populated. Now, manually mapping those kind of reference data sets is pretty time consuming and tedious. And this is why, the topic of my talk is about how do you automate this approach? How do you generate mappings automatically? And you see on the right some suggestions of the countries that that could be mapped. And you also see some confidence factors associated with it. So these are suggested mappings. And what you could do then is decide to either accept those mappings or reject them. And you could also decide that you want to accept only top mappings. What does it mean, a top mapping? Well, a mapping with a confidence that is higher than a certain number. So you could slide that confidence number, and then that determines, let's say, over 90, and that determines what's your top mapping. And then you could accept those as a group and then deal with each of your reference remaining codes that may have not been mapped. You could deal with them individually, either accept, reject, do manual mappings, associate nodes with your mappings, because mappings are not necessarily simple, and maybe you want to record the decisions as to why you decided to map X to Y. So for the future, that will become important. In different contexts, there can be different mappings. Also, to help with this process, often using a workflow may be important, and we support that, because instead of just moving these mappings to production, you may want to do a workflow where a group of people look at it and see what they agree, disagree with, and only then it's committed to production. So essentially, it's a combination of automatic mappings and with human curatorship by stewards, etc. Now, because we are in RDF, it's very easy to support many-to-many mappings. And you could see an example where, Australia, AU from ISO is mapped to two different FIPS country codes, and vice versa could happen as well, because it's a graph. We are not limited with a kind of a relational spreadsheet type of limitation, and can easily capture that. So how does this automated approach works? by default, the default algorithm uses labels. And as we just heard, a good practice is to reuse existing properties from existing vocabularies. And typically, the properties that are used for labels are RDFS labels, CAS-pref label, etc. And that's what the algorithm targets. And then, of course, in some vocabularies, reference data, for example, SNOMED, MASH, etc., there could be custom predicates for labels, and they could be specified as well. Technically speaking, underneath there is a Lucene index, and then there is some fuzzy matching is done using text processing and that Lucene index. So it works quite fast. But this works well for reference data where there are common names or similar names, and therefore you could use this kind of algorithm. Sometimes this does not exist in reference data. So it's possible to plug in your own matching behavior, your own matching algorithm written in some computer language specific for that reference data. And also TopQuadrant Edge supports rule-based inferencing using a standard called SHACL. It's a W3C specification. So you could define SHACL rules, which is a very rich rule language, and specify that if these properties are like that, then this resource is matched to some other resource. And that's also supported out of the box, that kind of a rule-based matching. So anytime you do something automatically, you want to assess how well your approach, how well your algorithm delivers what's needed. And we actually done this kind of analysis for one pharma customer where the mapping was with SNOMED and MASH and some local ways to talk about diseases, body parts, symptoms, etc. And this, I'm not going to read this wall of text. It talks about how the approach that we used for analyzing how we calculated the percentages. I'm sure everyone will get the slides and could read that. So the result of this analysis is that it's actually performed quite well. And in terms of finding matches, what's typically in the search terminology is called recall, it's between 97 and 100%. And in terms of correct matches, which is typically is called precision, it's between 79 and 90%. So it's a pretty good confidence, and that means that users could just bring their confidence threshold up and be comfortable accepting all those top suggestions. So once the reference data sets are mapped, of course, you want to use that crosswalk, and you could use it from any of the reference data sets that you've connected this way. For example, we see here that the FIPS Coral Islands are mapped to Australia, and since this is a graph, we immediately can expand ISO instance Australia and see all this additional information and have access to that associated it with this mapped reference data set. And sometimes you may want to then export those results, and now that they are mapped, you could export it back, for example, to a spreadsheet or whatever format you want, and not just information about FIPS country, but also associated ISO countries, and then information available for ISO countries, because it's all interconnected.
I keep in mind you have about a minute left. I'm so sorry.
Yes, thank you. I am close to the end. And since it's based on the standard knowledge graphs RDF, of course, you have access via Sparkle and can query Sparkle. Another access point that we found very important is through GraphQL. Very important because it's so widely used by developers, by applications. Not everyone knows Sparkle, but today GraphQL skills are very widely available, and then the application like to be delivered JSON, and that's why we support, in a very seamless manner, anything that you have in TopQuadrant Edge, you could seamlessly and automatically access through GraphQL. GraphQL schemas are automatically generated from ontologies, and it gives you very rich and capable query access, as you could see here. So you could use that to get some crosswalk services. For example, what is mapped to the reference data item with such code. And that brings me to conclusion. If you have any questions, my email is on this slide. It's very simple, Irene@topquadrant.com. And also a few links that may be useful for people. We have many videos, white papers, blogs, and you could also, if you want to try it out, you could also ask for evaluation account and see how this type of approach could work for your reference data.
Okay, Irene, thank you very much. Irene Polikoff of TopQuadrant. One quick question: how do you ensure the quality and consistency of the crosswalks?
Yeah, so that's a very good question. So I mentioned automatic mapping approach, and the fact also that people are involved in the curation and can assess mappings and change them, etc. Through using workflows, etc. So that's one thing. But the reference data evolves, and consistency is not only at the point of time, but it's also going forward, because maybe some codes have changed, maybe some codes are no longer used and dropped, etc.
Right.
So we use a validation approach. Again, it's based on W3C specification called Chuckle. So you could validate the reference data sets, and you could see if they are still consistent, according to the specified, constraints. Also, what you could do, because this is a reference data in TopRight Edge, which is kind of a system for data governance and managing reference data. When you talk about consistency, you may be talking about the systems that actually use reference data. So there's automated way to push reference data to them so they don't stay out of sync. And then when there are changes, they can be notified and the reference data is pushed to them, or they could use it, query it in real time. And then there's also a way to validate data in your system, kind of connecting from the system to TopRight Edge, and validate if you're keeping it in your local table, is this table up to date with the standard?
Okay. Irene, thank you very much. Thank you so much. Let's move on to Julián Rojas at Ghent University, imec. I have a friend there who works in nanotechnology. It's a fascinating place, imec. And Julián, you're going to be talking about the ERA knowledge graph, raising data interoperability on the railway domain. Julián, please.
Thank you, Chris. That's right. I will start by sharing my slides. So I hope you can see them now.
Yep, looks good.
Okay, great. So yes, thank you, Chris. Yes, thank you very much for having me. My name is Julián Rojas.
Sorry to interrupt, Julián. We can't see your presentation.
I did for a second. Okay. Nope.
Yeah, we could see it for a second,
and then it disappeared.
Yes, thank you.
Okay, let me try to share it again. How about that?
There we go. That's it.
Yeah.
Can you keep it on? Yep, there we go.
Okay, so just to quickly come back to the topic, then yes, my presentation today, I will be talking about a project we have been working on in the last year together with ERA, which is the European Railway Agency for Railways, where we try to develop a pilot prototypes to prove how or to explore how semantic web technologies and link open data technologies will support or increase the data interoperability on the railway domain, which is a very fascinating domain and especially challenging domain for data interoperability, because here in the European scenario, even more so, given that there are multiple actors that interact here to carry out a very critical service, which is railway transportation, not only for passengers, but also for cargo. And having all these different organizations that are related or are involved in these operations makes it very difficult from the data perspective to have interoperability across the different systems that reside on these organizations. For example, across Europe, we have what they are called the infrastructure managers, and these organizations, there could be even more than one per country. They are in charge of managing and evolving the railway infrastructure. Think of the railways and the stations and all of the things that exist across Europe, and each of them have their own systems internally where they manage this data. At the same time, you have the other organizations that are in charge of operating the actual vehicles or the trains that operate on top of this infrastructure, and they need somehow to come into or to agree on how they can perform this operation. So here is the task, one of the core tasks of the European Railway Agency for Railways, is that they put forward a set of base registries to help to create or to achieve a certain level of harmonization on the data that represents all these facts. And for example, we have here three specific ones, which is the RINF, which stands for the Registry for Infrastructure. You have the ERATV, which is the registry for authorized type of vehicles, or the ECCVR, which is the Virtual Registry for Vehicles. So these base registries bring a certain level of harmonization for the data, where these organizations have to or are required by the European legislation to put forward their data inside of them, so to facilitate interoperability. However, as we have seen, these registries quickly become what is referred to data silos, because they serve a very well-defined purpose. But whenever new use cases arise where you need that the data come from not only one registry but more of them to need to interact, then you bump into interoperability issues. And one very clear and common use case from the railway domain is the one that we talk about here. For example, we want to solve the question, what are all the compatible routes with vehicle X from Paris to Amsterdam? And this simple question already involves data that resides across these three different and independent base registries. Vehicle X definition is, for example, is residing in a DCVVR registry. Vehicle X has a type which defines its properties, and that type definition and those properties resides on the ERATV. And yeah, of course, the registry of infrastructure contains all the information that allows us to know which are the possible routes that this vehicle can take. So having this interoperability across these registries is not in place out of the box. So we need to already try to find a solution for this. And the problem, the fundamental problems that you encounter when you try to align or to create this interoperability is that machines, they struggle to interpret equivalent data that comes from different sources. So for example, in RINF, you have the properties of a truck. Let's say that the train detection system, it's a property that they handle or they manage there, and they have a certain definition for that. But in ERATV, they have for the same type of concept, but this time talking about vehicle types, they have a different definitions. So a machine who encounters this, they cannot automatically infer or understand that these are talking about the same things. So yeah, one can think that a simple solution is let's name the columns the same and problem solve. Well, there's still problems in terms of the data values that are there. So we in this audience, we already are aware that a solution for these are reference data sets. Reference data sets are independently maintained and are maintained by domain experts who defines, for example, what are the train detection systems, and where we can just lift the data contained in these base registries, following the principles of linked data. For example, immediately assigning unique identifiers to the vehicles, unique identifiers to the trucks, and refer to those reference data sets so that we can compare and we can create interoperability at the data level and not at an application level, because application level interoperability is it's only ad hoc, and it quickly becomes or it's much more difficult to reuse. So that's what we did in this pilot prototype project, and we created on top of these base registries what we call a semantic layer layer of interoperability, and we lift all the facts that resides in this registry into a knowledge graph. And we do so following a set of declarative rules. So we don't create ad hoc scripts to create this the RDF triples that are derived from this, but we do so following a set of declarative rules. And concretely, we focus on three main resources to develop in this prototype project. And the first one is that we did a framework or a data model that tell us how are we going to model the domain, and hence enter what we call the ERA vocabulary. And the ERA vocabulary, what it does is follows the semantic web standard definitions and standard recommendations to define a data model for the domain. And of course, trying as much as possible to reuse standard vocabularies. For example, when we talk about the geospatial properties of the entities that exist in the domain, we reuse GeoSparkle standard, and also we don't define what a country is. Instead, we rely on the taxonomy and the reference data set published or maintained by the European Publications Office for countries. So we already try to integrate and with other semantic available models for that. This model is created and maintained, of course, with the help of domain experts, and of course is open, and it can be further reused and also further evolved within the community. And the second resource that we created in this prototype project is the set of declarative rules. This is very important because this is what becomes the maintenance point for the knowledge graph. And we do it so following the technologies put forward by the RML stack. RML stands for RDF mapping language, which is a set of recommendation and tools that extend or build on top of the W3C standard recommendation R2RML to build RDF graphs from related relational databases, but RML goes forward to allow not only relational databases, but also other heterogeneous data sources, for example, most notably XML, JSON, and so on. Through these declarative rules, we are able to integrate additional domain and very well-known domain data models, which are not semantic by definition, but we can already integrate this data into the knowledge graph, and we can align as well to other semantic vocabularies or semantic models, such as, for example, the INSPIRE model, which defines geospatial concepts in Europe. And last but not least, our use case. It's the most important way to prove that our approach works. So we focus on the route compatibility check, which address the questions I put forward at the start. So how to reach, what are the possible or the compatible routes for my vehicle from Paris to Amsterdam, and this we did so following a cost-efficient architecture, where we don't expose our knowledge graph triple store to handle directly every single query that it's made to it, but we instead create an API layer on top of it that expose fragments of this data set, and an intelligent application, client-side application, is the one who actually performs the logic to answer this query. The server side only can focus then on maintaining the data set up to date and online, whereas the browser or the client-side application can focus on answering the core queries of the user.
Julián, you have about 30 seconds left. I'm so sorry.
Yeah, no problem. And then I'm finishing already. So
Okay.
we implemented into a prototype demo, which is available online. You can see it, you can play with it, and don't be afraid to make queries to it, because it won't take down our knowledge graph. And to finish and to wrap up, yes, so the takeaways of this experience project is that knowledge graph-based data integration approaches indeed facilitate creating interoperability or raising the interoperability across data silos or across base registries, and that they also significantly reduce the effort needed to extend or to integrate additional heterogeneous data sources, and that with the definition of standard of cost-efficient architectures, we can also support scalable solutions for different and multiple use cases not only in the railway domain, but also in other domains. So thank you very much, and open to answer any questions.
Okay, Julián Rojas of Ghent University, imec. Very quickly, could this tool be used in order to identify routes that are more useful than others and should be made compatible or more compatible than they are now? Very briefly, please.
Yes, indeed, the great advantage of this, the architecture we followed, is that you can tailor your algorithms towards what you need, and towards to take into account the pieces of data or the facts that you are interested in. So definitely you can steer it into your own liking. And yes, I think that
okay, great. I mean, how else do you make this railway directive, this single market supposedly for railways, work? It's what you're doing. You have to have some sort of exchange of data to be able to make things work better, and that's what you just talked about. Thank you very much, Julián.
Thank you. Thank you.
Let's move on to the EU Publications Office. Talking about EuroSciVoc taxonomy and EURIO ontology with Enrico Bignotti and Baya Remaoun of the Publications Office. Who goes first?
I will actually do the whole presentation.
Ah, okay. Okay, Enrico.
Okay. So you should see. There we go. Okay, so we should be ready.
Okay.
So okay, I am Enrico Bignotti. I work as a semantic consultant at CORDIS together with my head of sector, Baya Remaoun, and today we'll then present you the two resources we've been developing in CORDIS recently. So we'll start by telling you what is CORDIS, for those who don't know, and then also we will present then the two different resources we developed, EuroSciVoc and EURIO, and then give an overview of the next steps. So starting from CORDIS, from the basics, CORDIS is the European Commission's public repository and portal for almost all EU-funded research projects and results. As such, its content is divided in two. On the one hand, we have data, such as information on projects and results, for instance, project FOKUS. On the other hand, we also have editorial content, which are multilingual products that disseminate these research results, such as the Research EU magazine, which today reached its 100th issue, by the way. And so we have changed our role in time. We started as an entry point for project participants, but now we are moving to become a data provider of structured content. As such, this role requires us to perform data curation, so cleaning and enriching the content. And we do so by having two processes in place. The first one is automatic, so relies on algorithm, and it assures, on the one hand, data quality, so detecting and solving inconsistency in the data, but also data enrichment, so linking our data with external ones via multiple ways. And then the output of this process is validated in the manual process by information analysts using dedicated tools. But also the data creation process lies on exploiting semantic web technologies that we use to restructure our data model using RDF and OWL, and at the same time to exploit other technologies such as Shackle and Sparkle to actually create the data. So on the one hand, we have this restructuring, but also the semantic web technologies give us the way to link our data with inter and extra institutional one, thus increasing its value for the public. So in our experience, we developed two different resources. The first one is European Science Vocabulary, that is EuroSciVoc, which is a multilingual taxonomy of all the fields of science in CORDIS. And we need a taxonomy to categorize our project, firstly, to improve the discoverability for the user, but at the same time, to do so in a standardized way. And then we have the European Research Information Ontology, that is EURIO, which is the ontology I mentioned earlier, which restructures our data model based on the data about research projects that we have in CORDIS. And of course, as I mentioned, we use an ontology because in the long vision to link all the data of CORDIS with linked open data, it is necessary to go through with this type of technologies. So I'll start with EuroSciVoc. First of all, it's formalized using SCOSXL, which most of you would know. It's about 1,000 concepts, technically 991, which are translated in the 6 languages of the CORDIS website: English, Italian, Spanish, German, French, and Polish. And its structure, it takes the root from the Frascati manual taxonomy developed by OECD, and then is extended and enriched by extracting keywords from text of description that we have on CORDIS using NLP. It's been shared already with different stakeholders, mostly from the public sector, and it's regularly published on the Vocabularies website. Speaking of which, we have here how EuroSciVoc appears both on Vocabularies and on CORDIS. So on Vocabularies, you can see that you can navigate the whole structure of EuroSciVoc. You can see all the parents and children of all the different categories. And these very categories, of course, are used on CORDIS to classify our projects. And you can find them here in the field of science. Here we have an FP7 project called EpiStop. And here, instead of having the single concept, you can actually have the whole path all the way to the top concept, which in this case is medical and health sciences. You can see here they're exactly the same. But how do we manage? How do we develop EuroSciVoc? Well, we have this internal tool called SACS, Semi-Automatic Classification System, whose main objective is exactly to manage EuroSciVoc in all its life cycle phases, and also to perform the automatic categorization of the CORDIS projects. Here you see the landing page. Mostly, SACS is used, as I said, to classify, but it also picks up different indicators of the performance of the taxonomy classified projects. Here, for instance, you see what an information analyst will have for the category epilepsy. So you have all the different keywords that are currently used, some that are automatically suggested from the system, taken from the project text, and then all the projects that are currently classified under this category. In this case, you see, for instance, the previous project, EpiStop, correctly classified under epilepsy. But then, of course, there's a maintenance phase, which is overseen by the taxonomy manager, which consists in fixing issues that have been detected in the previous phase, and also extend the categories or changing them as necessary, and doing so based on the dashboard from SACS, where you have different queues that can be used for the taxonomy manager. For instance, there is this one here represents all the amount of documents that are classified in SACS. This gives a better understanding, a visual understanding of how well the EuroSciVoc is covering all the different domains of science that we have. For instance, you can see here natural sciences, it's rather big. And then there are more technical indicators that can be, for instance, that we have categories that are actually empty. So they're not classifying any project and basically useless at this point. Or the other way, which could be that we have overpopulation of a certain category, and whether there are enough keywords, enough validated documents, and you here also have other indicators. And all of these can be used by the taxonomy manager to really understand whether the EuroSciVoc needs a change, and if and how. And once these changes have been completed, then we enter the release phase where EuroSciVoc is ready, all the changes have been done, and we are then the taxonomy manager is allowed to export it for having the publication in the Vocabularies website, but also to have the taxonomy ready for publication in our internal system to then have an update on the website. So the new classification is available on the website itself. Then we have EURIO, and EURIO has been developed together with Everis. It consists of 26 classes, 62 object properties, and 45 data properties. The main point of EURIO is that we, of course, reused as many ontologies as possible, both those already in the EU ecosystem and also some used in more general areas. For instance, we use heavily on Dingo. We use also Frapo, but we also reuse ontologies such as schema.org, or the org ontology itself, and the project ontology. Similarly to EuroSciVoc, EURIO is also available on the EU Vocabularies website. Here we have a general overview of the ontology. I won't go into much detail, but just to show you that we have project as a pivotal entity, because of course, I mean, that's the majority of the information we have on CORDIS. But you can see also, thanks to this color queue, how much we reuse from other ontologies, such as Dingo, where one of the most important classes are grant information, but especially the element of role, which allows us to really detail how the organization and people are involved into a project. And also you can see here the reviews from other elements, such as the schema.org in the notion of events, the organization from the org ontology, and so on.
That's indeed mind-boggling. And how else do you manage that without having some kind of a data interoperability, right?
Exactly. I mean, the main point for us has been to, reuse as much as possible. But of course, the ontology is not just for show, because then, of course, we also need to use it really. And then that's where we have the CORDIS knowledge graph. And our knowledge graph currently contains almost 2 million different entities. And we also develop subgraphs of this knowledge graph that we called linked entity vocabularies. And these subgraphs focus on specific entities within the knowledge graph itself, such as organizations, grants, events, and so on and so forth, so that users could actually only use that one should they need to. And similarly to EuroSciVoc, we also developed an internal tool to manage the knowledge graph, which is called the Data Creation Tool, or DCT. And as you can see here, this is the landing page. These are the linked entity vocabularies that we currently have, with their the different types. So we have projects, postal addresses, organizational role, and so on. We have their validation status that tells us and the information analyst what is the ongoing process, how well it's going. And then also we have the different entities, the number of entities for each linked entity vocabulary, number of triples, and also the number of errors that, of course, are different for each type of entity due to its specificity. So I'll just go briefly over our next steps. We're planning, of course, to constantly update EURIO and EuroSciVoc and publish them regularly on the vocabularies. We also plan to have a Sparkle endpoint to be made available for users to play with and with our knowledge graph. So in conclusion, we try to provide an overview of how CORDIS has changed its role in the recent years, and how much work we put into creating different resources that perform different purposes, but all with the idea to create curated data that can be linked and used by the public, and link it to other institutions and other resources. And with this, I conclude our presentation. Thank you.
Chris, you're muted.
Sorry about that. Grazie, Enrico. A quick question, perhaps to Baya, who is head of sector. If I may ask a question from one of the viewers, is this tool open source, referring to the SACS tool? If not, is there a plan to make it available as open source?
Can you hear me?
Yes, I hear you.
Right, because earlier I had problems. So I'm not exactly sure about the rules, actually. I mean, it's a commission property, but I am guessing that it could be made available as open
Okay. Enrico, can you add anything to that, perhaps?
Okay. Well, I mean, the idea is, for the time being, SAX is still in, it's very advanced, but it's in a development phase. So it's been mostly used internally to classify our projects. It could probably be, but this is something more on general policy level. But yeah, it's fairly mature for its time. So before thinking of an open source, we still have to do some iterations, definitely.
Okay, another question, can SAX be adapted to work on other contents?
That is exactly something that we are working on right now, because I don't know if it was really understood, because it's a bottom-up, SAX is a bottom-up application, so the taxonomy was created with the content that we have, so with the projects that we host. Now the question has come up already, if we could classify projects from member states, for instance, funded by other programs, etc. And we have already done some tests on that, and it can be done. Yeah. Now,
Okay.
other content as I don't know, something completely different than research, there we will have to add other taxonomies, for instance, into the system. Train the system with those taxonomy, but I guess it can be done.
Okay, and I'd like to go to a break soon, but quickly, but here's one other question. Is it possible to browse EURIO without knowledge of Sparkle queries? The linked open data cloud is accessible without Sparkle queries.
For you, Enrico.
So currently EURIO is, I mean, all this, EURIO is published as an ontology, as a file on the Vocabularies, so it's not yet accessible in that sense. But with the opening on the Sparkle endpoint, it will be possible, of course, to traverse the whole graph. So it will be, there will be, of course, some base queries that will be made available. But for the time being, we just published the ontology first. Now, later on, we will have the actual Sparkle endpoint to do the actual queries or traversing the whole graph.
Okay, very good. Enrico Bignotti and Baya Remaoun, thank you very much from the Publications Office of the European Union. We'd like to go to a break now, and please do come back. We'll be back with you at 16:05. So it's less than 10 minutes now. We'll be talking to Fabian Kirstein of the Fraunhofer Institute, fascinating place. It does a lot of R&D. It was a very good source of information for me when I was based in Berlin, on the European data portal. So we'll see you at 16:05 CET, and we'll see you then. Okay, let's start. Welcome back to ENDORSE 2021, and this is track 2. Talking about solutions. Make sure to tweet #ENDORSE 2021, and you can send your questions in. In the bottom of the screen, you can see the chat. You can send those questions in, and we're talking now to Fabian Kirstein of Fraunhofer FOKUS. Fabian, you have been working quite hard on researching and software developing at Fraunhofer for open communication systems. You're also a PhD candidate at Technische Universität Berlin, and you worked on Open Data Portal for the city of Hamburg. So very interesting work you've been doing. Tell us about it.
About Hamburg or about this one now?
No, yeah. No, tell us about this one, the European Data Portal, large-scale application of semantic vocabularies. Yeah,
thank you. Yeah, I'm happy to be here. I'll try to make it very brief. Usually I can tell for hours about the European Data Portal, but I will do it with a focus on semantics and especially semantic vocabularies. 1 second. Yes. What is the European Data Portal? You maybe know it already. It's Europe's linked data-enabled one-stop shop for open public sector information. And it was launched by the European Commission back in 2015, and we are working on it since then. And it's not only an open data portal, it's an ecosystem, an entire ecosystem for fostering the manifestation, reuse, and quality improvement of open data in Europe. And I looked it up yesterday again, or last week, and as of March 2021, we have more than 1 million data sets, so it's 1.2. And we have in total more than 1 billion RDF tuples. And we are harvesting this data from more than 80 data providers currently. And Fraunhofer FOKUS is one technical partner in a consortium which is developing the portal, and which is led by Capgemini, actually. And what is especially important is that we are a pioneer in adopting DCAT AP. Earlier in this track, we had the presentation about DCAT, and this is DCAT AP. I will talk about in a second. And we were actually the first reference implementation of it. And on the right side, you see a screenshot of the registry, of the dataset registry of the European Data Portal. And DCAT AP is an application profile of DCAT, and it is designed to describe public sector datasets in Europe. It is based on DCAT and therefore based on the resource description framework. And what it does, it makes extensive use of controlled vocabularies and reference data, which is provided also by the European Union Publications Office, which is called then European Union Vocabularies. And you see on the right side, you see an extract of the specification where you, for example, see that there's a DCAT theme, which is linked to a vocabulary list and so on. So it's quite well specified. And the issue was, and still is a little bit, that those linked data principles and RDF vocabularies, they do not fit well to established open data solutions, for example, like CCAN, because they use relational databases and you cannot really store those information, or it's not represented well. So what we did, we developed a novel and scalable platform for harvesting, managing this kind of metadata of the European Data Portal, and we made semantic web, controlled vocabularies, and especially DCAT AP first-class citizens in our solution. And this just, I don't want to get into much detail, it's just a general overview about the technology we are using. We have a triple store as our primary database, so all the data, the primary data source is a triple store. And we use a microservice architecture, we have single-page application front ends, we use the asynchronous programming paradigm, we have the newest deployment mechanisms of Docker and Kubernetes and so on. But basically our architecture is divided into three main parts. We have a harvester for getting the data, we have a registry for storing the data, and we have a quality service for assessing the data. And what I want to do now is just go through the process or the life of a data set, which starts with harvesting. And we have a scheduler which periodically triggers our harvesting process, which is then done by an importer, which gets the metadata from our various source portals. We have a lot of we have support for a lot of interfaces, for example, for CCAN, for RDF, for Sparkle, and so on. And then we transform the data. If it's not already DCAT AP, we have to transform it. We're using a very lightweight scripting-based transformation here, which is written in JavaScript. So we're getting the data, transforming it. I've looked for an example. Here's a data set of the EU Open Data Portal, which is not our portal. This is the Open Data Portal of the European Union itself. This is the data set about the coronavirus, and you see it's already in DCAT AP. And we are getting this data and putting it in our portal. And if it's in our portal, we're doing the following. We have a middleware which interacts with the triple store, so we're putting the data set in there. We apply some URI transformation, we generate unique IDs, we do interlinking, and so on. Then we index the data set with Elasticsearch, actually, so we have a nice search functionality. And here we already apply some vocabularies and ontologies. I will show an example in a bit. And what we also do, we are using the European Union e-translation service to translate a subset of the literals into all European languages. And we store those information also in RDF using the multi-language features of RDF. So this looks like this, for example. The original data set from the EU Open Data Portal is now in the European Data Portal. And we transferred the URI to our namespace, and then you have the data set available in Sparkle and in various RDF formats. And what we also do, for example, here, they're using the vocabulary of the publications office. So we're using this vocabulary and we transforming it into human readable representations in our front end. For example, the publisher here, the European Center for Disease Prevention and Control, is then properly displayed in the front end. And we're doing this with a lot of control vocabularies. For example, also for the data themes, which are then used in our faceted search. And also you see here an example for the multi-language feature. This is the same data set automatically translated into Bulgarian. So, and in the last step, we're doing a quite extensive quality evaluation. We are also using here official W3C standard, which is Checkle. There is a Checkle specification for DCAT AP, so we are validating the data sets against this specification, and we store all violations. And in addition, we also check the accessibility for each link distribution, so the actual data. And we do further checks about the completeness. We evaluate the format, the type of data. We are checking if licensing information are available. And from all those information, we create a report and using actually also the data quality vocabulary. So another RDF specification, which is then attached to the actual data set. And you can download this report and either as RDF or in the human readable version. An example here would be this. This is the same data set again, the coronavirus data set. And you see there's a Checkle violation. For example, here that the spatial information is not the correct class. And also this looks, for humans, it looks like this. You have a nice front end where you see, okay, and this catalog has the following quality metrics. And you see here the FAIR. It resembles the FAIR principles, findability, accessibility, interoperability, and so on. So those are the 3 steps: harvesting, storing it, and assessing the quality. What we learned here in all those years now is that still linked data and RDF are a big challenge. They still are. And we believe that the very correct implementation of DCAT and especially DCAT AP and the use of those controlled vocabularies are still evolving. It works quite well, but there's still some way to go. And sometimes all those specifications are often complex and not clearly defined. And in our case, especially DCAT AP, the vocabularies, the Checkle, they do not always interact very well. So sometimes you have a property in DCAT AP, which is defined with a certain vocabulary, but this vocabulary doesn't fit the property, for example. So we believe that we still need more close collaboration between all those stakeholders. But as a conclusion, an end-to-end application of linked data principles and all those well-defined controlled vocabularies will foster the dissemination, reuse, and improvement of open data in Europe. And we believe the EDP is a well-known one-stop shop for open data, and especially an advocate for the linked open data movement, because we use all those RDF, semantic web technologies, and so on. And the European Commission has established DCAT AP and European Union vocabularies as a standard, and the European Open Data Portal acts as one enabler for its broad adoption. And you actually can see all the source code. It's on open source. It's on GitLab. You can access the registry, and it's European Data Portal.eu data. You can access the Sparkle endpoint, the quality page, and the entire portal just www.europeandataportal.eu. Yes, that's basically.
Very good, Fabian, Kirstein. Thank you so much, Fraunhofer FOKUS.
Yes.
A couple of questions from the viewers. Is there something that the Publications Office or EU vocabularies in particular could do in order to improve reuse and quality of open data in Europe?
And they're doing just fine. Like I said in the slide before, that we need to work more together. The people who are doing DCAT AP need to align better with the vocabularies, and we need to maybe give better guidelines to the original data publishers how to use the vocabularies, because they're very openly defined, and people always, some people do it like this, other people do it like that, and we then need to realign it. That's an issue. So better communication.
Better communication. Okay, next question. In what way the unification of a European data portal and open data portal will improve the services provided to the users other than clarity of the message?
Sorry, which?
Yeah, it's a little bit unclear. In what way will the unification of the Europe EDP and open data portal improve services provided?
I guess whoever asked this means the unification of the European data portal and the EU open data portal, I guess.
Yes, probably. Yes, most likely.
Yeah, that's an ongoing process, and we are doing this in a couple of months. I guess this will be just clarify things, because you have those two portals, and I guess the end user is a little bit confused. So they go to the European data portal, and then you go to the European Union open data portal. It's confusing, but basically it's just for the end user an issue, in my opinion.
Okay, all right. The next question. The visible pressure to develop large-scale semantic solutions seems to be directed to support institutional actors to help them become efficient and effective. Are there also benefits for the end user in such large-scale applications?
Yes, there are, because if you do it like this, if you have it in that scale in Europe, and you unify all the data, you create a common view, a single point of truth about all those data sets in Europe, and it's just a big benefit a huge benefit for the end user.
Okay, I think we got time for one more question. Regarding the checks on the level of fairness, are you considering the indicators suggested by the Research Data Alliance FAIR data maturity model, or have you defined specific indicators for governmental data?
Actually, currently it's just inspired by the FAIR principles. We are not, it's actually complicated to implement it directly, so we're working on this. It's just, we took those 4 principles as a guide for us. It's not perfect yet, but we will improve this in the future.
Okay, I might just mention also EDP's Gianfranco is on the meeting too. If you have questions or find us in the networking area, that's what I'm just reading this from the messages sent. Vielen Dank, Fabian, and yeah, and let's move on to George Filikan, Lights on Data, to talk about 3 artifacts to manage your metadata and reference data. George, you are founder of lightsondata.com, and you're co-host of the Good Data Morning Show. And I don't know, I could ask you about that later, but why don't you go into your presentation first?
Hello, everybody. My name is George Filikan, and I'm very, very excited to be here with you today, albeit it is in a virtual fashion, considering the circumstances. But I'm very excited to be talking to you about the 3 artifacts to manage your metadata and reference data. So, as I mentioned, my name is George Filikan. Really quickly about myself, I've been doing this for more than 10 years now, been really a data governance practitioner. I'm currently the Director of Data Governance and Business Intelligence within the University of British Columbia. But if you don't know me already, I can tell you that I'm really just exuberant about data governance and data management in general. So that's one of the reasons why I'm a frequent speaker and writer, contributor, YouTuber. As much as possible, I do try to provide practical information to just help you with any data governance and data management questions and challenges. So please check out lightsondata.com. A lot of great articles there and templates and even online courses. Or if you prefer content in video format, please check out my YouTube channel where I post a video each week. Or just follow me on LinkedIn. I promise you will not be disappointed. And yes, as I mentioned, I do have a few courses, 3 of which you can see right here. One on learning how to create an award-winning business glossary, everything that you do need to know on data governance maturity models, and my latest one with Donabel Santos on data visualization for data storytelling. But don't forget to get in touch with me and just connect with me on LinkedIn. I really always enjoy meeting new people in person or online and just listening to your feedback and sharing ideas and information. So please do get in touch with me. Now, on to our today's session. The reality is that there's really an ocean of data out there. And no, I'm not referring to data lakes. What I mean by an ocean of data is that really regardless of the organization size, regardless of the size of the database or databases, we are all confronted with a lot of challenges when it comes to data, especially when it comes to metadata. And these challenges are some of the impediments of becoming a data-driven organization. We hear that a lot. We need to become more data-driven. Well, we need to find different ways to navigate this ocean successfully and discover as much as we can and as much as we need to in order to answer questions to give us insight, hindsight, and foresight. Because we need to conduct the strategical as well as the operational objectives as best as possible. So that's really why we have all these data management areas and data governance. Now, there are these 3 artifacts. These 3 artifacts that will help an organization really navigate this ocean of data, this ocean of questions and answers on data integrations, reports and dashboards, master data management, reference data management, data analytics, data governance, etc., just a little bit better. So that's what we are going to talk about today. We're going to talk about what each one of these items are, these 3 artifacts, business glossary, data dictionary, and data catalog, how they differ from one another, what are some of their benefits, and how they interact with each other. So a lot of great stuff there. And by the way, if you are confused about these 3, it's normal because there are a lot of very different similarities, different similar terms that we can find out there. And sometimes they are used interchangeably in a wrongly fashion, especially by some of the people providing, different products that would solve your problems. So it's very, very normal for you to be confused. We're not going to go over each one of these, what they are and how they differ. But what I can tell you again is that these 3, you will encounter them the most often, and no, they don't mean the same thing. So let's start with the first one. Let's start with the business glossary. Now here's the reality. Making assumptions on meanings of business terms such as what's customer, what's a citizen, sale conversion rate, credit, GPA, you name it, is really what creates challenges in the workplace. I remember this one story. It's my story, and that's why I remember it. But I was interviewing for a technical job in a nonprofit organization for which its main business role was fundraising. When I was inquiring more about the teams that I would be working with in my role, the interviewer told me that they have about 200 people working in development. And now, because I was coming from a software development background, my immediate reaction was, wow, okay, 200 people working in development, in software development, that's a big team. I mean, I knew that it was a big organization, but I couldn't imagine they had such a huge team. Well, from the context of the conversation of the interview, I realized that development was really a synonym for fundraising teams. So they had 200 or so people working in a fundraising capacity, not in a software development capacity. Now, the message here is that wrong assumptions happen, and meanings of business terms are not always known, especially when you're entering a new industry, but also when you're switching organizations or even offices, departments. So what is this business glossary? It's just a collection of business terms with their unique definitions and other related information. And there are three keywords here that I want you to focus on: business, unique, and information. So really, we're talking about the business metadata, the business terms, business language, business verbiage, whatever synonym you want to use. We're talking about having this common place, this trusted source of information where anyone can just go to and understand the business terminologies and even other relevant information about these terms that just provides us more context on, especially on their usage. Now, I think we're all somewhat familiar with business glossary because we encounter them in reports, documents, books, manuals, and it looks something like this, usually towards the end. But the reality is that it's so much more than that. Regardless if it's spring or summer, autumn, winter, I really feel like it's Christmas, regardless of the season. It's that gift that keeps on giving. There's so much more that business glossaries can provide. So let me give you a couple of examples. So as I mentioned, a business glossary holds definitions of business concepts and its related semantics, its ontology, its meaning. And a business glossary is comprised of terms, the business concepts, and really other information. And let me just zoom in here a little bit to try and give you this example here. I don't know if you can see it very well. We're looking at this term that's called email address. Obviously, it can be any other one, but I try to make it as relevant as possible to anybody that's watching this. And we have the definition underneath, but then we have all these other attributes, and they can vary in terms of the number of attributes that you want to hold. But you can have things such as taxonomy, the business units that are responsible or the office responsible for it. What's the ownership, the data curator, status, acronym, abbreviation, synonym, providing some examples, usage descriptions, any notes, any policies, any security standards that you want to relate this one to. And of course, you could also hook it up to some IT assets as well. All right. Now, to be at its most effective, a business glossary must also be readily and easily accessible within your organization. And not only that, but we need to remember that it's business owned. It's business language which is controlled and updated by the business. Although facilitating the updates and management of the business glossary itself, the tool, often falls on the data governance organization or within IT or operations, depending how you're structured. But it's a tool. It's a great tool that enables clear communications within your organization, within your office, within the enterprise, between IT and the business, and even with regulators. And now we're already jumping into the benefits here. And there are a lot of benefits. I'm only going to touch on 3 of them, but it does improve communication. As I mentioned, we all come in with all these assumptions based on our life and work experience, and we tend to just bring them into the workplace without always validating them. So it does enable that consistent communication between business unit. And I think the term really customer is the perfect example for this, because most of the time it doesn't mean the same thing as it does for, procurement, between that and supply chain management, sales, marketing, IT. All of these would have different interpretations of what that word is. And I'm sure that you have at least one business term that you can think of that you always have conversations about. You always come in with all these assumptions, and it doesn't mean the same thing as it does to that person next to you. I'm sure of it. It happens so many times. Too many times even. But obviously, we must strive to use the same glossary as much as possible and same terminology, because reality is that using the same terms for the same things is really hard enough inside the organization, but obviously it doesn't stop there. With the rise of the entire digital transformation, we, as well as our machines that we're working with, will increasingly communicate with business partners in the business ecosystem. So yes, we must strive to use the same glossary, or at least know how different business glossaries map with each other. And this starts with knowing your own. So that's a big, big benefit. Also establish that ownership. It's, let's say, a very wanted side effect of having and establishing a business glossary, the fact that it creates ownership. And it's really the individual or the unit, but most likely the individual, that needs to approve this. Somebody needs to get a sign off when the definition is in place, and whenever any changes to its attributes need to occur. That can also connect with the data stewardship, but it does create that ownership. It does create it when it's being built. And this also creates engagement, because people tend to be more engaged when they have responsibility over something. I hope you can agree on that one. And it also improves productivity, as well as the timeliness of decision-making process. Now, you would definitely have faster development of dashboards and reports. Not necessarily the written reports, but reports that are based on data. So why is that the case? If you've ever worked with a business intelligence team or an IT team that had to develop these dashboards, these reports for you, or maybe you are one of the members of that team, you know that there's quite a hefty cycle to create them, because there's so many conversations that need to happen on the definitions on what goes into those reports. What do you mean by this column? How should it be calculated? How should it be interpreted? What is the context? What is the definition? What about here? What about the second page? Should it be the same? There's a lot of conversations about the meanings of things. And if you're lucky, at the end of the project or throughout it, you would have documentation that's created that would capture all of this. But even if you're lucky, most of the time those get captured in emails or maybe some meeting notes from all these meetings that you were part of where these decisions were made. And maybe a year later, when a similar report needs to be put together, developed, well, if the same people aren't there anymore, and even if they are, you forget after 12 months, and you start making assumptions again, or you start going through the same conversations, same hefty number of meetings and hours that you have to spend in closed doors and come to a conclusion. Not if you have a business glossary. Now you have this curated, trusted source that's centralized. You know it's being managed. You know, again, it's being curated. You trust it. You refer to it. If a change needs to occur, you go through the proper change management process and change it for everybody as well, if that needs to occur. But overall, it does improve productivity. The business intelligence teams, the IT teams see a lot of productivity, a lot of time saved just by having this clarity in place. So that's what the business glossary is. Let's step on to the data dictionary. Now that's maybe on the other side of the spectrum. We talked about the business metadata. This is more on the technical metadata. It gives you it's basically a repository of information about data that provides the description of data elements as well as its metadata. And I think, again, the easiest way is to take a look at an example of what is here on the left-hand side. Let me make this one bigger. There you go. And by the way, I'm trying to be very tool agnostic in my presentation, so that's why you're seeing maybe these in a more plain fashion. If you were to have a tool, it will look a little bit fancier than this, but that's basically really what it would capture. This is, again, just an example. So you see things such as data type, size, allowed values, default values, constraints, relationships to other data elements, and sometimes even meaning and purpose of the data set in each field. So a little bit of an overlap with a business glossary. But the business glossary is the business term as a whole. The data dictionary captures that term in that table for this context. It's a little bit more specific and a lot more technical. Now, that being said, the data dictionary and the business glossary, they do talk to one another quite a bit, for the most part. Sometimes organizations just choose to merge them into one. And depending how you want to tackle it, it can be done. So the data dictionary provides a very application or technology-centric view of the data. It provides the description of a data element and its metadata, as I mentioned. And you can have many data dictionaries, one for each application or system. But for the business glossary, because I haven't mentioned that before, usually just have one for the entire organization. Now, there's also the concept of a passive data dictionary and an active data dictionary, which I won't cover now because it's not in the focus of this session. All I'll have to say, though, is that when a passive data dictionary is updated, it's done so manually and independently from any changes to the database structure. With the active data dictionary, it's kind of the other way around. The dictionary is updated first, and changes occur in the database structure automatically as a result. Now, the benefits of the data dictionary, and again, I'll keep it to 3. Now, whenever developers need to program anything that has to do with capturing or consuming data, such as a web form or a piece of software or a dashboard or report, it's really very useful to understand the technical metadata behind the data elements. And that's one of its main benefits. It really clarifies those business and technical requirements. Let me give you a quick example. Let's say you are a developer, you're developing a web form to capture a customer name, and you should definitely know what the technical metadata should be used so that it doesn't really have any unwanted repercussions. Why? Maybe you are designing it to be a field varchar of maximum 32 characters, but the database that's storing it, it's only 16 characters, that varchar field. Once that happens, you'll obviously run into issues because anything that's bigger than 16 characters that's captured by the form, it will be truncated and you might not even know about it for a long time. So it's also forcing the programmer to also ask those questions from the business analyst, technical analyst, whoever they're working with, if they haven't thought of it already. So it does create some consistency in data use. It also accelerates training because ask any developer who recently joined an organization, the hard part about learning their new stack is not really deciphering the code itself. Well, sometimes it is, but it's really more about bringing context to it. There's really a reason why it takes several months for any new technical hire to be fully ramped up on their new company's, CRM, ERP, CMS, whatever big system you have in place. And database documentation is definitely critical in getting your technical and often more costly technical employees up to speed as quickly as possible on the application that they're maintaining or building. And lastly, at least as the third benefit, it does improve master data management, and as a result, also reference data management. And this is really especially true when handling the integration of databases that don't share the same vocabulary, but they do share similar data. Such as whenever you're inheriting, let's say, a CRM or a database of another office or another organization or company during an acquisition or merger, or you just want to create a new business relationship between them. But not only that, anything that really has to do with master data and reference data, it does help. It creates those efficiencies. So that's what the data dictionary is. On to our last one, the data catalog. And I think the easiest ways to understand the catalog's purpose, the data catalog's purpose, is to kind of think back of whenever we used to have those product catalogs, and maybe we still do, right? For IKEA, you kind of flip through. The only thing we don't do right now, we don't order from the catalog. But back in the day, you kind of pick and choose whatever you want to order, you mail it in with your check, cash, what have you, and a few weeks or months later, that item would arrive. Well, now we kind of have something similar, but a lot more improved. The catalog 2.0 or 20.0. We have things like Amazon. Amazon is really a good example of an online catalog. And Amazon carries millions of different products, and yet as consumers, we find almost anything fairly quickly. So for example, I want to find a book about moving abroad. I'm putting that into the search box. I see all these books. I click on something that is relevant or it's deemed to be relevant for me. And I see all this other very interesting metadata, such as, there you go. We see things such as, where are you? Oh, okay. Different ratings from other customers. We can see the type of book. Is it paperback? Is it electronic? Is it, glossy cover? All these other similar items and a bunch of other metadata from, who was the publisher, how many pages does it have? What's the weight? So forth and so on. Now, data catalogs, believe it or not, really work in the same way for your databases, but they can be also used for any data lake or data warehouse, any data store really. So a data catalog is an enterprise-wide asset that's providing a single reference source for the location of any data set required for varying needs. Needs such as, operational, business intelligence, analytics, data science, AI, so forth and so on. The purpose of the data catalog is really just to organize the thousands or millions of an organization's data sets to help the users perform searches for specific data and understand its metadata, as well as data lineage, uses, and even how others perceive the data's value. It's really this single point directory that offers the user the ability to locate information and further provides a mapping between the business glossary and the data dictionary. And we don't have time to do this right now, but I do encourage you to check out data.gov. This is the US government's open data. And it's a great example or a good example of a data catalog that you can find and implement. So a lot of benefits there. It does support regulatory compliance because all of a sudden you know what type of data is where. It does foster that data culture because it can facilitate frictionless discoverability. Now you are empowered to find out whatever data you could use for whatever project. And it also increases trust. You know the data sets that have been added in here are curated. Kind of similar to how artworks are displayed in a museum. They're being cleaned. You have the description at the bottom on that plaque. Somebody went through the work to really explain it and what it is about, and it's in a stage and state that can be consumed. And similar for your data catalog. So what's the relationship between all of these? Well, on the left, we have the databases, which are being ingested into the data dictionary, and they get surfaced into the data catalog. So all that technical metadata can be found or at least referenced from the data catalog itself. And the business glossary can also go between both of them, actually, the data dictionary and the data catalog. So there you have it. We have the business glossary, data dictionary, and data catalog. Remember that ideally you should only have one business glossary, one data catalog, and you can also have multiple data dictionary, one for each system. So I do hope that you do have a better understanding what the differences are between the three artifacts, and there you'll be able to implement all three and just navigate this ocean of data and metadata and reference data a lot better. Now, don't forget to get in touch with me and connect with me on LinkedIn. I always enjoy meeting new people, as I mentioned, in person or online. So thank you so much. It was really a pleasure to be here virtually with you. Thank you.
Our thanks to George Firicon of Lights on Data. Thank you very much. We're going to take a quick break. We'll be back in about 2.5 minutes at 16:50 CET with Miroslav Liška of the Ministry of Investments of the Slovak Republic. So we'll see you then. We are on track 2, talking about solutions. And I'd like to introduce to you Miroslav Liška of the Ministry of Investments, Regional Development and Information of the Slovak Republic, who's going to be talking about semantic interoperability in his country and his government. Miroslav, please.
Miroslav, you're muted.
Okay. All right. Hello. So my name is Miroslav Liška. I am working in the Minister of Investments, Regional Development and Informatization of the Slovak Republic, MIRI. And I would like to show you our, say, way to the semantic interoperability standards. I would like to share a few insights from the history and focus on what's important for this year. All right. So, okay. I would like to talk briefly how we started to work with interoperability standards in Slovakia, and very briefly we'll mention actual challenges that we have, and in the end I will focus on the objective. So we started to work with semantic interoperability since 2016. In that time, I was working in a business sector, not in government. And me and several of my good friends like Marek Šurek, Peter Hanečák, or Martin Tuchyňa, we were excited about linked data, especially in government, because we were developing several applications, linked data, and we find out that there is no public RDF resource that we can consume. So we decided to start to discuss this topic. We become part of the Slovakian standardization data work group and start to communicate what the European interoperability framework is, or what is ontology, RDF, URI resource, and everything. And what we did was the first proposal of central ontological model of base registers that we managed to create. We also transformed several code lists to the SCOS taxonomies, and of course we created the DCAT APSK, core public service vocabulary APSK, and several examples. So these were only standards, yes. However, what was, let's say, our greatest achievement in that time was that the central meta-informational system of Slovakia Republic, the META-IS, was extended by URI registration subsystem. Yes. And
Miroslav, while you took a drink there, I'd just like to remind people that they can put their questions into the chat at the bottom of the screen. Feel free to send in your questions, and hopefully we can get to them after your presentation. Okay, Miroslav, please.
Okay, thank you. All right, so this was actually very important because now what you can see on your screen is the system, and you can see a list of URIs that were registered and approved with the standardization group. And so this is a really what we think very important. And after that, also our ontologies of base registers were published on this META-IS. So anybody could work with this data. There were also published examples of taxonomies that were transformed from code lists. So you can actually you could build any solution with this kind of data. All right, and in the, let's say, end of this era, we created LOT Slovakia, link open data. It was a graph of several transformed base registers into RDF, and this version in 2018 was focused on agricultural fundings because it was hard time in Slovakia. An investigative journalist and his fiancée were murdered because actually the last article of the Jan Kuciak article was about agricultural fundings. So we focus on this topic. And as you can see here on the right corner, we created also a movie about it, the Graph for Jan movie, which shown how interoperability is very important in public information systems, and of course transparency in everything. And we were honored by European Commission, and we were invited into CEMIC conference in 2018, as well as in the SDI Next, and we were presenting in great community of Link Open Data Netherlands as well. All right, so that was history and our challenges right now. So the first, of course, that central meta information system doesn't contain RDF triple store. Yes, this is a really key factor, and it is not possible right now, for instance, to query those data through the, for instance, Sparkle endpoint or something like that. Yes, and additionally, actually, the fact is that right now there is non-semantic tool for maintaining ontologies or taxonomies in our government. And the third, let's say, obstacle, which is right now very important for us, that our once and only principal project, which is data integration, is not aligned with the semantic interoperability standards, but we believe that we will solve this soon through the legislation. Okay, and so what is the plan for this year? So as you can see here, we are right now currently working on the Slovakian knowledge graph. Yes, sorry. Okay, and as you can see, we are going to focus on extending the ontological model because we would like to include more data from other base registers. We are going to transform all the reference codes into valid SCOS taxonomies. The additional important thing is that in Slovakia, actually, we are going to build new data, central data portal, because right now that what we have doesn't support DCAT, so we actually going to jump directly into DCAT 2 version, and of course we are going to use core public service vocabulary application profile as well for publishing electronic or public services. So the goal is very clear. The first is deploy this knowledge graph to triple store, yes, and provide real data services. And we are going to use open source for that. Okay? We are in a, let's say, initial time of adopting semantic interoperability in government. So I think it's good start to use only open source, for instance, like Cosmos for publishing taxonomies, or Protégé for developing ontologies. And for instance, the triple store will be very simple, RD4J for start. Yes. Okay, so this is kind of the goal number one, to have the data alive, not just published for download. Then the second thing is, in order to establish the, let's say, better understanding or the semantic interoperability, is that we are going to create more distribution of the ontologies that we are having, because of course, let's say ordinary developers or project managers are used to rather use UML or XSD or XML, and the RDF technology is not so familiar. So we believe this could help to establish the understanding. So this is goal number two. Like you can see here, it's a person, physical person representation. It's physical person represented in 3 different representations or formats. You can see XSD, UML, or RDF. All right, number 3 goal for this year is creating DCAT profile for publishing mandatory data sets of Slovak Central State Authority. Yeah? So this is going to be also supported with legislation that each Central State Authority, like ministry or something else, has to publish defined set of data sets. Like you can see here, like public orders, what they have, public invoices, public contracts, public fundings, and others. So of course, since we are a ministry as well, this is our task to do, yeah? And we are going to publish everything in RDF. So this is our goal number 4. And the last one that I would like to talk about is, again, LOT Slovakia or Link Open Data 2021. What you can see, as you can see here, so in the center there is a knowledge graph, which will consist reference data represented as link data. Of course, our publication minimum of our ministry. Okay, so those orange are, let's say, complete. But for sake of understanding and showing what the interoperability really is, we're also going to at least partially publish data sets from the public contract register or legal subject register, address register. And what we would like to do also as well, not purely out of the government data, is to create also one link data representation of our Slovakian news, which are, for instance, related to transparency, anti-corruption and everything, and link it together and provide, of course, portal that you can search, export, and do an analysis on top of those data. So this is the 5th, and that's everything from my side. Thank you for your attention. I'm very, very happy to be here and to share these talks with you.
Miroslav, thank you very much. I've got a question for you from the viewers. What are the reference taxonomies that you use and how have you created them?
We understand reference taxonomies. For instance, those taxonomies we are using are on the national level and international level. For instance, those international level, on this level, we understand using, for instance, European taxonomies, for instance, like data catalog, country, or others, whereas our national taxonomies will be created out of the code lists that are used in the base registers that are shared between those registers.
Okay. Any other questions, please put into the chat. We can take another minute or so. When you were mentioning the agricultural payments and investigative journalists, has that uncovered new information that journalists have reported on? Is that continued now?
I think we had a hackathon in Slovakia. It was a hackathon all for young, and there were many teams that solved the problem. And actually, I think everybody helped, since until that time, until that tragic event, actually those data were published very, very badly. And so it was not possible actually to understand the data and see who was the requester of funding, who was the receiver. So we put data together. I don't mean just our team, but also other teams were very great in this.
But you think that maybe is helping in bring more transparency then, I guess, to government operations, not only in Slovakia?
Absolutely, absolutely. I think the interoperability and this linked data is a really perfect, let's say, thing toward transparency, because otherwise, really, if the government is not good, and there are not good governments in our world, they tend to hide the data, right? And really make the hard to just see the obvious things.
I think that's worth a hashtag tweet, hashtag endorse 2021, if anyone would like to tweet that as well. Okay, thank you very much, Miroslav. I guess we can move on at this point, unless there's anything else you would like to add. We have a couple of minutes.
I'm okay. I'm okay.
Okay, Miroslav, thank you very much. Very interesting presentation. Let us then move on to our final speaker, who is Joseph Busch of Taxonomy Strategies. He's talking about the role of standards organizations in the USA and their impact on knowledge representation in the global context. I notice, Joseph, you are founder of Taxonomy Strategies, which guides companies, government agencies, and NGOs in developing metadata frameworks and taxonomy strategies, including in the medical and banking sectors. So that's quite interesting to discuss. Joseph, go ahead.
Great. Thank you. Thank you very much, Chris. Thanks for the introduction. So first, can you all see my slides and hear me okay?
Yes, we do. We see, yes, we see your first slide, yes.
Okay, excellent. Thank you very much. Yeah, this is, I was asked to put together a talk that provided some information about the context of standardization and from the USA's perspective. I'm based in Washington, D.C., so I'm, kind of in the heart of the U.S. at this time. But I work very much in the global context and want to frame this more broadly, but do some level setting, because there often are a lot of assumptions about the USA and certainly about other countries and groups as well. So, broadly, in these days of the 21st century, we've heard so much about how data information and information technology is this foundation for publishing and interchanging and using content. And it's a key driver of business development and growth. We've been, kind of looking at a lot of different examples today, and we will over the rest of the week. But at the end of the day, this is really central to the economy and to the way that that business operates, as well as governments. So this talk's going to provide an overview of the basis for standardization in the US, the roles of various types of standards organizations, their impact on knowledge representation in the global context, and I'll provide some examples of these activities. And I'll be focusing primarily on standardization in relation to information management, publishing reference data, and semantic interoperability, the big themes that we've been talking about today and well for the rest of the week. Let's see. Oops. Okay. Right. So let's talk first about kind of the U.S. government policy towards standards, because it's a bit different than in other countries and similar. So in the U.S., intellectual property and privacy rights are fundamental rights. They're defined in the U.S. Constitution and its amendments, and specifically in Article 1, Section 8, Clause 8 of the U.S. Constitution, the Congress is given the power to, quote, promote the progress of science and useful arts by securing for limited times to authors and inventors the exclusive right to their respective writings and discoveries. And then in the Fourth Amendment to the Constitution, it explicitly protects the right of privacy against unreasonable searches and seizures by the government. And then the Fifth Amendment provides for the right against self-incrimination, which justifies the protection of private information. So, I mean, this is, it's important to understand these go back to the very essential founding documents in the US. But of course, the way that they play out in terms of the 21st century is interesting and peculiar and different than how it plays out in other countries. So, so what actually is the US government's role in the development and use of standards and conformity assessment? And the central document here is a much more modern one, but it's not that recent. It's from the end of the 20th century, and it's referred to as circular number A119, or the and it's called, and it's referred to by its name, the National Technology Transfer and Advancement Act. And there's other laws and regulations that are related to it, but this is really the central document that establishes this concept of voluntary consensus standards, which is really central to the way the US government, at least, views the standardization process, that it's a voluntary and consensus process. The one thing the government does do is to monitor or assess standards conformity. It's not necessarily in order to be prescriptive, but to be more of an assessment, to create the conditions in which standards can be adopted, but not necessarily, and actually not typically through regulation, with some exceptions that are related to copyright and privacy and those sorts of issues, which are familiar and part of the general process internationally. Oops. Go. Right. And something else that's important to mention, I used to work in the culture sector in the context of humanities processing for a long time, and I'll mention that a little bit later. But one of the things I encountered, because a lot of my work was international, was that there is no culture ministry in the US in the same way that you find in most other countries. So again, even in the context of culture, there's this notion of voluntary consensus that's a little bit different than the context in other parts of the world. However, there are these parts and locations in the government that are different than they are in other governments, where these same activities go on. And it's worth mentioning in the US that the US Department of Interior, which is mostly known for the national parks and monuments of a natural sort, also are the stewards of many objects. And they're the largest museum system in the US and probably one of the largest in the world. There are more than 73 million objects under their stewardship, and they have a huge archive as well. So it's something people don't necessarily realize, and it is and functions much like a department of culture, but not exactly in the same way. And then the other body that's very prominent and that many people know about is the US Library of Congress, which is not really the National Library, but it often assumes that role. And the reason I bring it up is it's also been a focus, and I'll talk about this in a minute, of standards that are very important and relevant and have been talked about already and will be talked about more during the rest of this conference. But the primary mission of the Library of Congress is, just as the name says, it's to provide service to the Congress, to the legislature, the legislative branch of government in the U.S. to do research for them. And I personally have done some work for what's called the Congressional Research Service, which is the part of the Library of Congress that specifically is a research arm and provides research to the legislature on any issues that are requested by the legislature, either in the US, that would be either the Congress or the Senate, or the House of Representatives or the Senate. Okay, so that's kind of the baseline. So let's kind of turn from that, which is kind of the federal governmental situation, to what actually happens on the ground in terms of the types of organizations that are impactful. And some of these are, not just U.S. based, but they have had a strong presence in the U.S. and then have often become a more international and gone beyond their narrower origins. So I'm going to talk about each of these briefly in a minute to give a little more background. But the first group are government agencies. I've mentioned the Library of Congress, but I'll talk specifically about that. And the other is something called the National Institute of Standards and Technology, which is part of the U.S. Department of Commerce, and that is the agency that holds many technical standards. And the Library of Congress is the agency which is often delegated the authority to deal with many of the standards that have impacted publishing and information interchange. There's also a lot of nonprofits in the US, and Dublin Core started as it was hosted originally by an organization called OCLC that many people know, which is the originally Library Consortium, operates something called WorldCat. It's very active in Europe as well as the US. And then spun off and has become much more of an international organization, and is no longer a US-based organization at all. It's very global and very successful. Many people at this conference have been involved with the Dublin Core over the years. And another body that's a nonprofit, not a government agency, is the National Institute for Standards, which is the US standards organization that is the ISO representative locally. And again, many countries have their own offices that function in that way locally. And those are what we call membership nonprofits, meaning that institutions are the members, not individuals, and not government agencies particularly, but institutions. And those institutions may be for profit or nonprofit. There also are a lot of private nonprofits in the US, and these are commonly called foundations or philanthropies, and it's a very big sector in the US, partly because many people who've made large amounts of money have sold their businesses and then put that money into various types of philanthropies. One of them I'll mention is the Getty Research Institute, which is was essentially known as an art museum, but also has a much bigger footprint and was very instrumental in many standards which have had a big impact around the world. And I worked for the Getty for about 10 years back in the 1980s and 1990s. I'll talk briefly about the Getty Vocabularies in particular, which was one of the programs in the Getty, which is a private nonprofit foundation that was involved with the Getty Vocabularies and other things. And then finally, there are industry trade associations. And this is the other big thread in the US where businesses create organizations that, among other things, advocate for their interests, but among those are the advocating and through this consensual process for standards that allow for certain kinds of products and services to be able to be built, used, and sustained. And I'm going to talk about two of them. One involved with the creation of computer technology, most related primarily to semiconductors, and then the other, the software and content industry association in the U.S. Both very big players in standards, very influential in good ways and bad ways. Okay. Let's just see what else. So let's take a quick walk through this. So let's start with the Library of Congress. So the Library of Congress has been a global leader in bibliographic description, controlled vocabularies, and classification. These are all essential components of reference data. There's a chart on the right which is difficult to read, and it's just a selection of some of the standards that are developed and maintained by the Library of Congress, and these include resource description formats. I'm always categorizing things, so I've sort of divided these into groups. Some people might argue with my categorization, but to give you a sense of the areas that the Library of Congress is involved in, which is much broader than simply bibliographic description. But the description formats like BibFrame, which is a data model for kind of more contemporary one for bibliographic description. There's a lot of library standards, and one that I'll note is called PREMIS, which stands for Preservation Metadata Implementation Strategies, which is a digital preservation metadata standard that's very important for archives and has been very influential globally in moving that forward, although, again, it's an area that I think the U.S. is no longer the thought leader in. There are information resource retrieval protocols such as Z39.50, which was a very early communications protocol for searching and retrieving information from a database over a computer network. And it was this evolved before the internet and was very important in early capabilities for online public access library catalogs. They're also involved with general information or resource retrieval standards such as ISO 639. And we heard Jona talk about, I think it was in the solutions track, it was in the reference data track, which is a current project around languages, and the European Office of Publications has a reference data set of languages. But in the US, the Library of Congress is the body that is the host and maintenance agency for ISO 639. And then just straight out controlled vocabularies. An example of that would be the thesaurus of geographic materials that enables consistent resource description values. So, traditional value vocabularies. So we have the whole range. We have these metadata vocabularies, so the DCAT sort of resources, and we have these value vocabularies. And then everything in between in terms of the information retrieval protocol. So it's a very important and essential agency in the US, and still very influential. And yet it's not the National Library. It really is in the service of the legislature in the US, but still very important institution in our context in the US. So on the other side of standards are standards related to materials, or to, for example, to calibrate measurement systems, and then reference standards that relate to certain disciplines. And this is an area that the government does take a fairly active role in, so that because it's central and has been for a long time, and this is true globally. to enable the basic ability to for commerce to function. We need to have agreements on measurements and reference sets. But the other thing I wanted to mention is that, because we don't always know this, that the National Institute of Standards also has been instrumental in facilitating automated categorization of text and image content through a program called TREC, which stands for the Text Retrieval Conference. And this is something that's not as well known, although those who work in the information retrieval community are well aware of this. But it's worth mentioning that this is the locus, and it's within this National Institute of Standards and Technology that a lot of the early research and continuing research activity around text and image retrieval has been centered. And what's helpful here is that as publicly available resources, there are these large data sets which can be used as baselines for information retrieval development and research. That is generally framed under the context of what's referred to as AI, sometimes correctly, sometimes incorrectly today. But there are really useful sets of materials related to legal, medical, news, chemical, and genomics, and other areas as well that are publicly available and that are used for these specific workshops that are focused on sometimes domains, sometimes content types, and other sorts of activities. But it's a very significant player in this space, and it is a government subsidized sponsored program with lots of publicly available, very useful information. So moving over to the nonprofits, almost everyone knows about Dublin Core. It's probably one of the most successful and important internet standards that has been impactful in basic levels of description of web content. And it's been widely adopted publicly and commercially. It's also was one of the, I would say, first successful implementations of RDF. And it's been very instrumental in the development of both tools and adoption of RDF, partly through this huge impact on commercial applications and the web. But it originated very humbly in 2009 at an, actually, but I'm not sure that's quite correct. I think it was 1999, so forgive me for that. I think it was hosted at OCLC until 2009. It began much earlier. I believe it was 1996. Somebody out there can probably correct me. Forgive me. I'm sorry about that. But it's really important and impactful. It started in the U.S., but it was always a very international gathering. And when I worked at the Getty Foundation, this was something that the Getty participated in, and it was very important for them as well to, as part of the promotion of standards within the cultural heritage community. So on the more general standards side, NISO has been instrumental in promoting foundational library standards initially. So many of those standards that we saw in the Library of Congress side, their promulgation as standards more widely has been taken up by NISO, and then often these are brought to ISO through the NISO community. And this is a membership organization, so institutions, particularly publishers, are members of it, and some of the larger consortia as well. But it is not a government agency. It's a national or a public nonprofit, membership nonprofit. Okay, so the Getty Research Institute is kind of a strange and interesting thing. This is something that's very American. It's a private foundation, but they've been incredibly instrumental in promoting controlled vocabularies, particularly in the cultural heritage space. And those include the art and architecture thesaurus, notably, and the thesaurus of geographic names, which have both been very widely adopted worldwide. And there are some other parts to it. There's a large union list of artist names that continues to grow. And these projects have been going on for quite a long time. So they're part of the Getty Trust, which also operates the Getty Museum in Los Angeles. The original foundation, when it was formed, when the Getty Trust was formed after the J. Paul Getty Trust passed away, there were a number of people who were very interested in humanities computing, and this was in the early 1980s. So some seminal work on research on how humanities researchers operate, particularly art historians, but others as well, and then seeking out people who are involved in some groundbreaking types of activities, notably the art and architecture thesaurus. But then there also were a series of research projects, mostly based in Europe, that were related to building multimedia archives in the 1980s, way before the World Wide Web came along, that involved hitching up video discs and Unix computers and all sorts of interesting things. Quite a lot was learned by doing that about how to create robust data models, and ultimately these led to the creation of things like the CDOC data model, which has become, which was again another early instance of object-oriented thinking that ultimately has become kind of fully implemented, shall we say, in the semantic web. So it's important that the Getty makes a lot of material available. It took them a long time to get around to thinking about how to make this publicly available, and eventually they got there. It's available as linked open data. It's available as XML or relational tables. It can also be accessed via APIs or through Sparkle endpoints. But it also provides community-based terminology management, which is a really interesting and important challenge. And the European Union is a really good example of an organization that is also very committed to this notion of community-based terminology management. We know how difficult it is to create resources like EuroSciVoc. It requires editorial guidelines and training and validating contributors and setting up groups that can regularly meet and talk about these things. And I think we're actually participating in part of a bigger activity related to that here. So in the US, you don't see this happening very often, but it is in this case an activity that's been funded pretty consistently by a private nonprofit. In most other parts of the world, this is something that's more of a governmental or intergovernmental activity. All right, and then I just wanted to turn to these industry associations. So, and this is not unique to the US, but it's a very big feature in the United States. These industry associations that focus on developing protocols and standards that enable certain products and services to be built and created efficiently and effectively, basically create value. And a good example is semiconductors. And if you think about it, a semiconductor is a good example of a kind of a product that has absolutely no value without its documentation. And it only makes sense as a part of a bigger system. And yet it's become this these integral components in almost every product that's manufactured, or every complex product that's manufactured. But it all requires this great level of coordination and cooperation that's focused on documentation and training and terminology agreements and standards for communicating that quickly and effectively. In fact, you need the documentation before you create the manufactured product. Just a quick story, I did a project once for Nikon Precision, which is the company that manufactures the fabrication equipment that creates semiconductors. There's other companies that do this as well. The problem was around how to provide documentation to support that kind of complex manufacturing. And this is true in all kinds of manufacturing, which today has become incredibly sophisticated. So the point is that all of these ideas about standards percolate down and up through every nook and cranny of our economy. And a good example of that is the semiconductors, which we take for granted. On the other side,
Joseph, let me just jump in real quick and just mention to those watching that we would love to get your questions to Joseph as well as others, because the last 10 minutes of this session today, we are going to be entertaining questions from anybody to any of the speakers. So please keep that in mind. Questions for Joseph or anyone else who spoke today, please feel free to send them into the chat that you see at the bottom of the screen. Go ahead, Joseph.
Okay. So then just to sort of round out this section, just wanted to talk about one other organization, industry association, which focuses on the other side of technology, which is software and information. So this is the trade association in the US, and both SEMI and SIIA are international, but they are very dominated by the US and America, and for good and bad reasons. But this is the trade association that's more on the soft side and the content side. So it originally was just software, but it's become one that also includes the entertainment and to some extent the publishing industry as well. And they're focused a lot on effective intellectual property policies, because their whole business is based on having the kind of regulations in place that allow them to create products and services that are basically created on information or software code. So they're involved with public policy advocacy and then a lot of what they call best practices recommendations. So I think that's very relevant for this group. A lot of what we're hearing around the table, and we will this week, is information about best practices recommendations. How to use information, how to value information, how to make that information robust and contextualize it in lots of different ways. So at least in North America, the SIIA would be the other sort of area to look at as the kind of organizations that have a big impact on policies and standardization that are central and affect things. So let me just kind of tie this together a little bit. And again, apologies for a busy slide. This is something that you should look at your leisure, and you should be able to get these from ENDORSE, or these will be posted on the Taxonomy Strategies homepage, a link to them so you can download and look at this in more detail. But I wanted to, again, try to put these into context. These standards, which are created by all different types of organizations, have an impact on all of the things we've been talking about. They all have an impact on information management and publishing. And to some extent, they have a big impact on reference data and ultimately semantic interoperability. And we could sort of look at these as kind of a laundry list of the kinds of standards and guidelines that are needed to make this ecosystem actually work effectively. And it ranges from things that are more readily identified as standards, the different types of vocabularies, metadata and value vocabularies, the types of schemes and encodings and protocols, as well as documentation and best practices, which take many and varied forms and are really important to provide the widespread adoption, provide and support the widespread adoption. I've tried to provide a definition or a working definition of what each of these is. If you will, this is a business glossary around information standards, or the beginning of one that you might want to elaborate even further. So I started with this idea that the US is a little bit, has a little bit different way of approaching standards, this idea of consensus activities. But what I really want to say is that the standards really are drivers of certain kinds of activities, and the ones that are adopted and widely used are ones that have a very big impact. So we see that standards that have an economic impact on operations become widely adopted. For example, in the US, while we weren't involved in GDPR development directly, this is really something that comes very strongly out of the European Union. It's every US company every large US company that I encounter, and every software company that's developing software to support information management is absolutely obsessed with GDPR compliance and talks about it all the time, and is completely focused on it, in the same way that other software companies that are involved with operations in manufacturing or health and safety are absolutely focused on being compliant with the relevant ISO standards in that area. So even though these are not American driven at all, they have such a strong economic impact. That's what really drives the implementation. There's also things that happen at the right time and become widely adopted. And I think Dublin Core is a really great example of that. It happened to be there at the time the internet and in particular the World Wide Web emerged as the primary content platform. And it became widely adopted even without Dublin Core going out and trying to sell itself to each and every one of those organizations. It's ubiquitous. And it's widely successful and a very interesting thing, but it really was a question of being in the right place at the right time. And that's what really leads to these de facto standards. And there's others, we could say XML and RDF in a way also benefited very much from the same thing. And then there are standards that facilitate data interchange, and some of them are not, we're not talking about that much, but in the financial markets, FPML, Financial Product Markup Language, which is created by something called the International Swaps and Derivatives Association, or ISDA. It's essential. It allows businesses to communicate with each other over the counter to do transactions, and those sorts of standards emerge from those industries. They often involve people like us to help create them, but they're really being driven in order to allow business to happen without barriers. But within our world, SCOS and OWL, Simple Knowledge Organization System, and Web Ontology language are, become absolutely essential. And I think, Protege has been mentioned a few times, but Web Protege and certainly VocBench are great examples of how these standards really enable this to happen. And just to wrap up very quickly, I just want to kind of bring this back to one of the big topics which people are talking about is knowledge graphs, which is this new way of presenting information that's based on semantic relationships. What's the goal here? And we've heard a couple of different people talk about it. I'll give you my, just 2-minute kind of riff on this. This is about how do we represent an organization's knowledge assets, content, and data, or people, places, documents, multimedia, whatever. And the key thing is relating them together, linking them together. And that's what knowledge graphs are really all about. It's about the relationships between things. We've been really good, and it's really easy for people to understand what things are and even what the properties are that define them. But defining the relationships between things is really what's been revolutionary and is starting to become widely adopted. And when we start to build these relationships, we create what are called triples, and triples are basically the building blocks of knowledge graphs. Basically, this is what an ontology is. It's the definition of the types of relationships between things or instances. Okay. So you can take those nice sort of charts that I started with and put instances on top of it and relationships between them, and you begin to have sense making, and sense making of ontologies with instances is what a knowledge graph essentially is. And you see these, and they don't look anything like that. So on the right side, we have what Google calls a knowledge graph, or the Google knowledge graph. And we're looking at a concept called fluid dynamics. And what you see on Google, if you search for fluid dynamics, is a collection of information that's automatically assembled by Google, because they have been tracking these instances and making these relationships, and they know that these are all, they are, the relationships resolve to this concept called fluid dynamics. On the left side is something that's might be a bit more familiar, but it doesn't look anything like a knowledge graph, but it really is. It's something called physics subject headings, and you can go to this is a live website and see it. If you look for fluid dynamics, it's a discipline in physics, which is a concept that you don't necessarily even pick up on over on the Google side. And every discipline in physics has a related set of research areas, physical systems, properties, techniques, and then other types of professional topics. And this is a scheme that we developed together with the American Physical Society to reconceptualize the way that physics would be presented and used specifically for the publication, for facilitating the publications of articles as quickly as possible in physics. And that includes, how do we identify experts who can then referee and read those papers quickly. So it's again, another type of knowledge graph. Doesn't look anything like the Google one. Just very quickly, knowledge graphs can be knowledge bases, social networks, data catalogs, which there was one talk earlier in the solutions track that it warrants looking into more, and then combinations of these things. They're used to enhance search results, to personalize search results, to provide for recommendations by linking of entities. It's used for very unpleasant things like ad targeting, and then for things that are really interesting and not seen so much because it happens inside businesses, but to enhance data analytics. And I'm seeing a lot of this in projects that I've been associated with. So there's not a lot of knowledge graphs that are available off the shelf, but there's a lot of ontologies that can give you the framework. And I point you to bartok.org as a really good source. And there's over 704 ontologies that are identified, including EuroSciVoc. So there's lots of material out there to get started with. As far as instances go, there's a lot of resources that are available. There's DBpedia, Wikidata, and then the linked Open Data Cloud is probably the most important one. So there's lots of material out there. So how come this all happens? This is all happening because of standards. And the key standards are listed down here on the left side, and we've talked about a few of them, Dublin Core being one of them, but these sort of foundational standards, RDF and RDFS, SCOS-OWL, and then Link Open Data Protocol and Sparkle are kind of the key standards. I'm going to kind of leave it there and just sort of sum up the fact that standards, we've had a kind of a brief overview of U.S. standardization with a focus on data information technology. We've talked a lot about the U.S. approach to standardization. It's different from the more centralized approach that we see in other governments, but but American organizations and companies are often quick to comply with international standards because that facilitates their participation in the global economy and research environment. Because of the situation in America, I think we should, kind of reach out to thought leaders and key industry partners, just like we are in this conference, to work on standardization together and harmonization. And while the incentives may be different, there's still a shared goal, which is to facilitate effective data and information management, publishing reference data, semantic interoperability, and its use worldwide. Sorry about that big run through the end. There's a kind of lengthy bibliography if you'd like to see more about this. And like I said, please look for my presentation and at ENDORSE, or you can download it from taxonomystrategies.com. And thank you very much for this chance to talk to this meeting.
Joseph Bush of Taxonomy Strategies, thank you so much. And I've got a question for you. It kind of follows on what you just said about, about working together. Now that the Trump presidency is behind us and the Biden period is starting, do you see that this will influence U.S. standards organizations and their impact in the global context?
Well, I hope so. I think it's a little, to be fair, it's a little early to tell. And I think there's quite a lot of focus right now on trying to make an impact on the pandemic. And an awful lot of energy is really going in that direction. But I think clearly, as you say, the last administration was kind of America first. And I think that that's certainly not the case. I shouldn't say not the case, but I would say there's really been a very big change. But, I think we also have to be realists that there's an awful lot of people in the US of all sorts who seem to not necessarily be that unhappy about the way things were before. Personally, I think we have a much better climate for cooperation and coordination, and everything that I see happening is certainly leading in that direction. And I certainly hope that there'll be more openness to do this. I will say that I think there's one thing that we've found is, even though we haven't been able to meet face to face so much this past year, I think people have worked really hard to stay in touch through meetings like this held virtually. I've run a couple around knowledge organization, and others have too. And I think that's something that I hope continues. And one thing about online is that we are not challenged by getting from one place to another and the cost that entails.
Okay. I'd like to get back to you on another question or two, but first, I must announce this is the closure and Slido survey period, these last few minutes leading up to 1800 CET. So we've got about 6 minutes now, for all of those watching to link into Slido if you haven't yet, slido.com, and connecting with the event called #Endorse 2021 to put in what you think we should be doing in the future. What future steps should be taken after all you've heard about through these talks today? What form of recommendations do you have for the future? So if you could put those into that Slido, that would be great. And you can also send more questions if you like as we wrap up today. I've got a couple of questions here. I also must remind you that all presentations that you heard today will be shared online after Endorse. A question, let's see, hang on one second. I want to go to a question for someone else if possible, hang on a second here. Fabian, are you still with us? Fabian Kirstein. Haven't been able to look there. Okay. What about Antoine Isaac? I think you're still connected. Antoine, are you still with us?
Yes.
Okay. So here are a couple of questions. One is, do you have a strategy in order to improve the geographic and/or thematic balance in the input coming from different data providers and aggregators?
Yes, yeah, I think there was a similar question to which I've already answered yes and no, because this imbalance somehow represents our partnerships, so to say.
Yeah.
So we must also keep it. I'm not saying that we must cherish it, because that would probably be a mistake, because people don't expect us to do that. But we still must represent it while smoothing the edges and making sure that every institution gets represented in the mix.
Okay, here's another one. Currently, the submission to Europeana can be done either by institutional actors like libraries and museums, or as personal contributions, uploading stories in terms of metadata once submitted. What are the mechanisms that the wider public can, like in the case of Wikidata, help Europeana to improve its content?
So this is a good question. Thank you. Thank anyone who asked it. It's tricky. So as you said, there are already some mechanisms to source some content, but that's part of the campaigns to gather crowdsourced items. We are venturing into applying this idea to metadata. Having some campaigns to provide with annotations, but this is not yet rolled out at full steam, I would say. So it has happened in the context of specific projects, but generally there's, and I think that would apply to many things that were presented today. There's a problem of having to make coexist some very official data and metadata with things provided by the users, and we have to make sure that there is still trust in the system. Well, actually, to be honest, we have our quality issues, of course, as everyone, but taking some data from the wider audience would create a number of issues that we are not equipped to deal with right now. And it's not only Europeana, it's the entire cultural heritage sector. So there are some experiments and some really cool stuff happening, and we are building some infrastructure, but we still have to produce a sort of general framework to make those things happen.
Now, I heard from Miroslav, talking about transparency, fighting fraud through more data use. And I'm kind of wondering from both Joseph Bush and yourself, Antoine, about fakes, about in art and in culture, being able to prevent there from being fakes. Does this data help to fight that?
Yeah, this is why we are a bit hesitant about opening widely the gates to getting data from everywhere. So right now we are, so the trust is kind of grounded in our partnership with the cultural heritage institutions, and should we blur that picture, we would enter a completely different ball game. And yeah, that's what is quite difficult to handle. And I'm gonna let Joseph say something, because I'm sure he has plenty.
Joseph, would you like? Yeah, Joseph, what do you think? I mean, because I saw that, I noticed that Antoine, you work with Getty, right? And Joseph, you too.
Yeah. So I mean, the Getty was concerned about that, or I should say, people at the Getty were concerned about that. I mean, I think people in museums archives are very concerned about it. But I actually think that we also have to look at this more broadly, and I think that's what you were saying, Chris, because there's this problem about truthiness in all information, really, and even within organizations, even within business organizations, they're struggling with this too. And it's a key problem in data governance, right? It's data quality, and it's also this idea that if you want to create a governance structure or a framework which allows for organizational oversight, whether you're talking about something as high as high culture, or you're talking about something as low as, let's say, corporate data. There's still this need for, kind of this governance model where you create an ecosystem which allows for self-monitoring. I don't know if that's the right term, self-auditing perhaps. And even in the best of intentions, if we look at culture sector, which is which has lots of screaming examples, that might make us more concerned. I don't know that we have to make a distinction between those who are gaming the system and those who are simply not, maybe don't have enough information to make an assessment about whether something is true, correct, or proper. So it's not black or white. It's sort of a range of things, and that's why I think we need to frame this in a broader governance discussion, and also not put it on a pedestal, but think about it as applying to all information of all sorts. It's a very big issue and area to explore.
Indeed. Joseph, thank you, and thank you to all the speakers today, and to all of you who have been watching. And if there's anything you'd missed or like to see again, the presentations will be shared online. We will be talking tomorrow, day 2 of this ENDORSE 2021 on law as code and interoperability. I will be on track 2, fundamentals, including a workshop on building, enhancing, and integrating taxonomies. Keep in mind that the hashtag ENDORSE 2021 to send out any tweets from comments that you heard today or any comments that you would have. And also, if you have any further recommendations for the future, please put those on slido.com with the hashtag ENDORSE 2021. Thanks so much for watching, and we'll see you tomorrow.